start recording for now. Yeah, so we don't need to have the previous 10 minutes of silence.
Yeah, and I've been editing them before I send it out, just so that they start and people don't have to fast forward.
Right. And then we can start now.
Yep.
I see the recording has been stopped.
Nope,
Okay,
it started.
Okay. So I don't see Barefoot here. Ashok and Jay, do you want to go ahead?
Sure. I'm just trying to see how to share my desktop. Let's see.
You should see a box pop up. I just made you the presenter. There you go.
Yeah, so let's see. Does it show up?
Yep, we're seeing your screen. Yep.
All right, wonderful. Okay, just give me 1 second. Okay, now that's much better. Okay, so just quick recap. My name is Jay, and I'm from Broadcom. And the objective of this presentation is to propose some changes in the current telemetry APIs. And the way these APIs right now have been proposed, there are two drafts which are there in the SAI community. One is the TAM draft, which focuses on certain data sets, and the second draft, which is the Barefoot draft, which is the INT, and then it was renamed in the last meeting as a detail, as a data plane telemetry. And in the last meeting, we talked about that we should take a little bit holistic approach on this. Just 1 second, somebody's pinging. Bhaskar wants to join the meeting and he is pinging. Okay, so, and we wanted to take a holistic approach without being too much burdensome on the community, where at least we do a classification of the APIs a little bit cleanly, so that the implementation and the various functions which are provided by various vendors are easier to support. So that's the objective of this presentation, which I'm going to go. It's fairly short, and okay, and I have kept it around mainly three topics. One is that how do we see the API sets, how roughly they should be broken down. The objects which are currently defined in both the TAM draft and the detail draft are a little coarse, and they are very specific to particular implementation. So there is some extension on that which is used as an example. And then I have showed that how easy it is to migrate current set of APIs which are there in the detail, and they seamlessly fit into this proposal. So that's the agenda for today's meeting. Any questions before I go into the presentation? Okay. So this is a busy slide, but I will just start from the top. So if we look at it, the main objects which are in play for any telemetry and monitoring system are essentially the telemetry APIs itself, and that itself is a bigger domain. When we say telemetry data set, that data set belongs to various subdomain in a given system. So that is one high-level class which we want to address separately. And then the data can be collected from a system which is already operational and working, or it can be collected through a proactive mechanism like probes. So that's the second set of APIs which we want to incorporate. Events in current proposal, the way they have been, they are kind of very tightly integrated as a telemetry subsets. I think it's a better idea to separate them as a separate class in itself. And events, we have to look a little carefully, because events could be an atomic events, like a port going up and down, or just a threshold which has been crossed, or the event could be an event which is based on some aggregate set of data or aggregated set of events. So we have to separate them, and the main motivation is we should be able to apply some mathematical functions if we want to do some sort of aggregation. And finally, on that, we must also have an associated action. So I'll go in detail on that. And then same thing is with the reports. The reports are separated, and we want to be flexible in the API where reporting mechanism based on a data set should be flexible on current standards, or there could be vendor extension if we want to have any specific format to be supported. And finally, we should have a separate collector definition where collector can be a local collector, which is internal, could be an external collector. So that's the collector class. And then if we go down beneath this hierarchy, then it looks very much similar to what we have. The constructs are exactly like what the SAI community proposes. So there are a set of APIs. The APIs define the calls, and then there are various data types and data attributes which are semantically associated with the set of APIs. So that's the kind of hierarchy. I'll go in individual classes. Again, before I go into classes, I want to pause for any questions or comments. Okay. So the first class which we are addressing through this proposal is the telemetry class. And we have taken a stance, we have taken an approach on this class to break it down into certain functional blocks. And this is just our proposal. And this can be seamlessly extended. So just to keep that in mind. So the very first one is the per packet telemetry class, which is, as in today, we talk as data detail. Which are attributes which are associated on a per packet basis, which are either created by a given packet or are collected on a per packet basis. So that's the class. The second one is the flow class, where we do not want to burden the system on a per packet basis, but want to create telemetry objects for a given flow and want to collect it on a flow basis. The third is a switch instance, and switch as not in a switch or a router, but a switching silicon instance. So a system may have multiple instances of the switch, and we want to collect data on for a given switch instance. Example is various table sizes. We want to monitor the resource utilization. We want to monitor any given silicons. Some block, it behaves in a peculiar way. We want to monitor that. So that's this class of APIs which are responsible for doing that. The next one is the fabric, and this is mainly for a chassis-based system. If we are monitoring a chassis, or if we are monitoring a logical system, which is let's say a three-stage class, which is having a IP class part of the network. So there are different set of data set which need to be collected. So these APIs are going to address that kind of data set. And then there is an overall aggregate data set which can be collected, which is assigned to the networking element. This is pretty broad, so I don't know how much you want to put in there, but I have captured it just as a thought. So that's the first set of APIs, and the way we are thinking that they should be broken down.
What exactly do you mean by a networking element? Give a couple of examples of what a networking element is.
Right. So let's say that I want to collect information about a router itself, that what is this router attributes are, how many line cards, how much memory, what kind of controller, routing gin, things like that, aggregate level. And as I said, that this could be fuzzy. It also contains the control plane information, and this does not go into that part of it. But at aggregate level, maybe there is some interest in collecting identity of the networking element with some basic data set. And these APIs provide that.
But you know, the problem with this and with the fabric is that we have not defined them in other parts of the SAI. And it's fine maybe, but you know, it's something that we should actually consider. So we have no notion of a fabric, and we have no notion of a networking element anywhere else in the SAI.
I agree with you. Yes, and that's why I made it clear that I have captured it as a thought, and we have to delve into it. And if we think it's the right thing to do, then maybe expand on it.
Well, I think it's a useful thing to do. I don't know whether it's the right thing to do, but we should define the other, you know, what a fabric is in other places first. I mean, I would say that this is something that we want to reserve for the future. Let me click on it and consider it. And
okay, that's a good feedback. I agree with you on that. Okay, so I mean that's exactly what I was thinking when I was going through the code base, that the notion of fabric or the networking element does not instantiate itself in the other part of the SAI. And if we want to do that, then it's a little broader activity. But as a placeholder on the API set, it's very easy for us to start from there and put the API, which are essentially a no-op for now. Okay. The second set of class which I want to discuss in this is the probe API class. This is again based on my interaction with customers and the requirements and some of the IETF conversations which are going around. And there are implementations which exist for it in various form and shape. And I think it's a good idea to incorporate at least the APIs here. And in this, there are various kind of probes. I'm not going to go in detail, but the most probably commonly understood is the in situ IOM probes, which are defined by the in situ IOM draft in IETF, and this API set should capture those set of probes. So that's the second set of API. The third is the event. And as I was talking about it, the event, I would like to segregate them as an atomic event or aggregated events, either preferably through a direct API itself, so that I can attach various mathematical functions to these APIs, and that can be invoked in the data plane. And one thing which is missing in the current API set, actually I should not say missing, it is there, is the action associated with an event. And the only action today which was associated, I saw, is a reporting action, reporting as a report. Whereas action could be a little bit more sophisticated, which is a feedback loop going into the data plane. If I want to change a cost profile for a given flow, if it exceeds the threshold. If I'm doing some classification for elephants and mice, then I want to take some other action, maybe do a rate limiting, maybe generate an ECN message, things like that. So this framework will allow for more sophisticated actions based on any silicon's capability. So that's the event API class. And then finally, there are two classes, the report and the collector. And report class essentially gives us the flexibility to send reports in a flexible manner based on customer requirement or silicon's capability. And I have captured some of the reporting mechanism today which are supported, SFlow, IPFix, Solobov, or could be a vendor specific. And the final is the collector class. And collector class, the way at least I'm clear about internal and external, I'm still trying to put my head around that. INT metadata, the way it's generated today in int, should it be a separate in itself or class in itself, or should it be an implicit class? So that's something which we can debate on it. But internal class, just to go in detail, is think of a chassis system or a logical system where my collector is an internal collector. All the statistics which is collected from the line cards need to be exported to a routing engine or a soup. So that's what the notion of internal. We can argue that there is no difference between internal and external as long as it is addressed by IP address and a transport and a port. And I will agree with that too. So that's the collector class APIs. And underneath is a standard framework where the APIs get defined, and associated with the APIs are corresponding types and attributes. Any comments?
Now, what's an aggregated event versus an atomic event? And I did not get the event action very well. Like the mathematical function, would it be applied by the silicon, or is it something external? So, for instance, the way I look at aggregated event is a list of events. And then if there's a list of events, what's the difference between an atomic event and a list of events with one event? But, maybe I just don't agree what you mean by an aggregate.
Right. So let's take an example. If, let's say, I'm doing queue monitoring, and then I have a high watermark and a low watermark. Anytime those watermark crosses, that's an atomic event. That event does not need any other information to qualify itself. So that's an atomic event. There is nothing more than that a system need to do, right? So that's one example. If I want to derive, let's say, resident time for a set of flows or given flows, which takes information from multiple places and do some processing, or let's say I want to do a runtime mean computation, and then if the mean goes below a certain point, then I want to take an action. So that will be an aggregated event where I have to apply a mathematical function for already monitored information or an event. And that's just one example. There are many other examples which we can capture.
Okay, but that mathematical function is something that's performed in silicon.
That mathematical function can be performed in silicon. Yes, that's correct. And that's where the flexibility of silicon's differentiation comes in play, that if I have a richer silicon, which is capable of performing various mathematical functions, then expose them through this API class.
Okay. I think we'll have to see how the interface looks like first, but anyway, that's okay. And then the report API class. So we have, we have a few things like SFlow, protobuf. I guess, we have to, and then we have vendor extensions. So I'm just trying to figure out whether we really need to call each class, or whether we can. Anyway, we'll have an enum type, right?
Yes, it's going to be enum. Yeah, you're right. Probably. So that's a very good point actually, and that directly goes into the fuzziness which I had in my mind. Like telemetry API class, I'm very clear that that's a various set of APIs. But the report API class, does it make any sense to make a separate API, or we just make them as a type or just an enum type, right? So that's a good point. And we are working on the actual header files. And some of these details you will see flushed out there, that it does not make sense to make some of these classes as an API itself and just calling them out as an enum. It's not good enough. But for presentation purposes, just for clarity, I have captured it like that. But that's a very good point.
Okay, thanks.
I have a question. We already have a package called sample packet, which really defines a more generic way, or tries to define more generic way for sampling packets. So how it how you see it with having a specific S-flow or IPP? Like it looks as we already defined some infrastructure for sampling packets.
Okay, so here we are not defining a way to do the sampling. This is once we create a record, once a record is created, which contains either a telemetry information or a event information or a data collected through the probes, how do we want to send that record? That record can be essentially, what's my data decoration? Is my data decoration a S-flow record type, which is driven by the templates, or is it an IPFix? Is it more runtime dynamic in nature, protobuf? For sure, we cannot do protobuf in the silicon. So what this class is saying is that what are my data decoration methods? It's not defining an infrastructure for doing the sampling. Does that answer your question?
Once more look at, we need to go inside the details, but like I'm trying to understand why you put it as a report class. Like what is different in what you mean, why you combine them together?
Okay, so let's take an example. Let's say that the API enables queue statistics, and we have enabled fairly large number of queues. Let's say, pick a number. Let's say on one port, 16 queues, 16 port queues, and those that data is collected. Now, how do we want to send that data? What is my data decoration method on that? That is the question. I have multiple choices. I can send it as a TLV format the way I understand. In that case, it becomes a proprietary implementation. I can take that data and see if there is a corresponding template in S-flow or in IPFix record, and most of the silicons support these formats. Can I send that data into IPFix or S-flow format? That's my other option. Or if the data itself is very fungible and cannot be qualified in the switch silicon, then do I send it out as a protobuf packets? That's what this class defines. So based on any given set of data, API can specify that this telemetry data, let's say, pick an example, this flow-specific data should be sent out by a reporting class of S-flow, which is associated with a collector class whose IP address is this, port is this.
But as I understand, S-flow is a way how to sampling the flow on a, let's say, statistical way, how it connects to the queue information. Queue information is something different, and we defined in the SAM a way of tracker and transport, which we will bring it to the user of this information.
Right.
So, okay, so I still not understand what is the connection between S-flow and the queue statistics or buffering system.
Okay.
So Vitaly, can you hear me?
Yes.
Well, S-flow is not just for sampling. You can send counters, you can send other information by defining your own S-flow. I forget what they call them, but it's buffer types. So basically, you could use an S-flow encapsulation and send it to an S-flow collector who can deal with that particular buffer type. Okay?
So in this case, S-flow is simply a kind of tunneling the information.
Yeah, it's an encapsulation thing like IPFix or whatever, which is another possibility that you could use, or PSAMP, or I mean, there are different encapsulation mechanisms that collectors are set up to parse and deal with.
So that's something that in existing SAM we call a transporter.
It's related to it, yeah.
Okay. Thank you.
Anyway, I'll go back in the hole.
Thanks, Joe. Okay, so going to the next slide, this is just an example. It's not anyway a comprehensive. This is some of the extensions which I'm thinking to add, and I have captured them. So the per packet session attributes, today they have certain set of data, and they have been extended by some more information. And one thing which we are debating is to add a notion of, so when I say per packet, think of int. So this is essentially int data. Instead of calling int, we call it as a per packet data. In this case, there is the int metadata header. Right now, it's very constrained in the sense that it has only set number of fields, and that too in a specific format. We want to extend that, give flexibility to various implementations to support and not support various fields. So one way to do is through the template IDs, and an individual implementer can assign their own implementation via a given template ID and publish it in the SAI community that this is the template ID which I support. And on the type itself, it will be a union of all the possible fields. But a given ID will be essentially a subset of the fields which is supported by a given implementation. So that's a thought, and I have taken some example like in Broadcom's Silicon, we do support queue congestion information that was not captured in the current spec. We do support egress port drops. There is a notion of a hop count, which is supported in the metadata for various reasons. So these are some of the things which we can contribute, and then other people can also contribute seamlessly without putting them in a constrained environment that this is the format which everybody should support. So that's the idea which I am projecting here on the per packet session type. Another interesting thing, if you see here, there is a notion of metadata offset. It may be needed, may not be needed, but I thought, again, it's a good idea to capture it. So in data makes an assumption where it is inserted at the L4 boundary, and some implementation may want to change that offset to a different absolute value, or may want to do a tail stamping. All this attribute does is give you flexibility to, at default, we do it as per the int, where default offset is at the L4 boundary. But you can extend it to support various values wherever the implementation want to insert the metadata. So that's the thought on this one. The second one, on the report session, we just talked that we should extend the reporting formats seamlessly to other implementations. And then on the event also, I have captured the like another event. There are many more which we support, but like BST is another one which we want to support. And event will be again just a union of all the possible event types which are supported. So that's a little bit going, not too much in detail, but a little bit going into the attribute and types, that how we are thinking to enhance it. And then the last slide is, which essentially says that it's very easy for the current detail spec to migrate to this this infrastructure. So they have so right now in the current detail spec, if you see the event reporting and the telemetry APIs, they are all a single blob. So we essentially tease them apart. The APIs which are specific to telemetry goes into the per packet API class. The events and the reporting, which are kind of combined together, need to be separated, and they have to implement a separate reporting class, which need to get binded with the event, because their action is reporting in the event. So that's just giving a very top level view that how the migration of the detail API will look like. And at least in my opinion, it's a very easy migration. So that's all I have to here to present. There is a header file definition which is work in progress. We are writing it down. It is by no means complete. Let me see if I can.
Got a question on your slide number 4.
Okay.
If you could bring it up. Right. So in the report session attributes, I don't see the source port.
Yes. So in the current spec, the source port is left fungible.
Is left what?
It's left for the implementation. It's fungible. So there's no explicit specification of the source port. Yeah, but we should capture it. Yes. It is not there, but we should capture it, right? This is not complete by any means.
Okay. So,
yeah.
so could I use this using report session attributes and give a 5-tuple in the report session attributes, and basically be able to get an answer back of the form that it tells me which port this session is following, or what would I get back, for example? I'm basically looking for using, let's say, the report session attribute API, and say, I want to give you a, I want to give you a protocol, source destination IP, source destination ports. Tell me which way it's going to go, or which way it's going.
The flow is going to go? Is that what the question is?
Yes, given that 5 session attributes.
Oh, I see. Okay, I see. Okay. Well, so that's okay. That I'm going to go back. So that's actually in the probe API class. So probe API class will give ability to specify 5-tuple or maybe more if it's a tunneling traffic, and then you can use this API to say that this is my 5-tuple. Tell me which way this flow is going. That's the probe, and you can do two ways. Either you can go through the in situ IOM way, where it supports the Genevieve and the VXLAN GPE, or you can create synthetic probes, which is whatever your format. And there's a proposal we have on that too, on the probe headers.
Will I be able to? Right, I understand. So will I be able also with the emulation of probes to say, I know you don't have this 5-tuple, but where would it go if it were to come in?
That is correct. Yes, you can do that too. Yes.
Okay, excellent.
Yeah. Yeah. That's not in the report. Report API class is explicitly for defining way to send data across the wire to a collector. Okay, I was showing the draft which we are working on, and it is
for implementing some of those APIs. What sort of time frame are we looking at?
Ashok, are you on the call?
Or are you actually from the list? Let's say you, for example, I'm throwing out a random number there. We have 100 APIs. Have you grouped them or prioritized them so that we can know what we're targeting first, or and what?
Yes, right. So my focus is to bring existing implementation up to speed, meaning I'll be focusing on the per packet API and the flow API. Switch instance, we will bring it later on. We already have a work in progress for the probe API class. This we will bring it in. Event API, we have some aggregated events, but atomic events is probably get prioritized. And the report API, this is actually, I don't think that's that big of an implementation. So we can bring this in fairly in a complete sense. So my priority is to get the per packet and the flow get going. On the probe, except for in situ, we have both emulated and synthetic proposals already in place. Event API, atomic will get priority, and report probably you will get, report and collector probably you will get in its entirety. And on the exact timeline, I don't know if Ashok is online. Ashok or Bhaskar? So we can get back to you on the exact timelines. That's not a problem.
Okay. Yeah. I mean, I'm really interested in the in a couple of things. The probe API class.
Mm-hmm.
I think they're really useful, and it will help us tremendously on our day-to-day operation. Find out what the heck is happening.
Right.
So it'd be great if we can have timelines, or if others think it's also useful to see if we can somehow prioritize.
Okay, so yeah, so from our side, we definitely have a proposal on this already. It's not just cleaned up and not translated into the headers, but we definitely have it on the priority list.
Hi, may I ask one question, please?
Yes, please.
Yes, I'm J.K. Lee from Barefoot. So when we presented the kind of detailed watch list to define a set of packets or flows to monitor, one of the major comments we received from the community was, why do we repeat the same ACL-like API? So we actually converted our watch list API into SAI ACL API, just using exactly same as the SAI ACL table. So do we see such a kind of convergence or connection to the ACL interfaces, or what you presented here, this telemetry API class for the flow, is something completely new?
Yeah, it is completely different. So I see what you're saying. So here, flow is, think of it as let's take an example that, let's say I have capability to identify elephant flows, and then I want to report my just the elephant flow information. What is the 5-tuple, how much bandwidth they're consuming, how long they have been alive, things like that. Okay, or I want to just, in a very simple way, send flow statistics, right? So there is a flow which are being monitored, and we attach a counter to that and measure just the flow bandwidth, things like that. So this is not ACL at all.
So how do you identify flows? How do you mark flows as flows being of interest? So
flows are already going, right? All you do is attach a counter to that, and right? Yeah. That is based on that. If I'm doing a more sophisticated action, then I will not just only collect the statistics. I will do more, and then probably do the classification if they are elephants or mice. Yeah. So I think this is this is one of the main disconnects, I think, between talking about control plane telemetry, where you're trying to mostly gather statistics and counters, and the in-band data plane telemetry, where you actually want to track and tag particular packets on a per flow basis that you specify of interest. So, this is an interesting discussion. I think it looks at telemetry from a different angle than I think we have been focusing, in terms of there is an aggregation of telemetry functionality that is control plane driven, and that should be aggregated. And there's a set of telemetry function that is data plane driven, and those are distinct and separate. And there's value for aggregating those APIs along that boundary, but I don't see a good alignment in terms of trying to aggregate APIs across those boundaries, because they affect very different feature sets in terms of telemetry information and features that you can enable. Yeah, I don't agree with that. This is not a control plane telemetry APIs, and I've been very careful in specifying that. That's the whole reason why I left the networking element as open, that it's just there, but I'm not sure what we want to put in that. It is very specific to data plane, and as I said, that you might be thinking control plane because maybe Silicon is not able to do that. I have an instance where Silicon is able to do such things, and I purely think them as a data plane information.
So, however, according to your descriptions, I think the flow is different from what the int has been defined. I think, as I'm understanding, your description of flow is mostly like tracking flows, identify elephant or mice, but I think it's different from the int process in terms of they want to just do the match and the actions. So basically, your flow is you kind of in your ASIC you do the flow classifications. You have your own ways to do the flow classifications, but in their case, it just matching, define whatever the customer specified definition of flows and do the matching actions. So I think there is it's not the same based on my understanding that your telemetry class, the telemetry flow class is different from what the int proposal has.
So I think what the one thing which I observed, which we have been, I came to the community a little bit late, so my apologies for that. One thing which I observed, we have been looking at it in a more as what implementation I have, and then how can I abstract that implementation in a given API. And I said in the beginning of the presentation that I'm taking a more holistic approach, that the goal is very clear. It's we are focusing on the data set which is relevant to the data plane. That part is clear, right? So there's no question on that. But what use cases I can solve, right? What problems I can address? What is the data set which not just myself, other switch vendors can provide? So that's an aggregate set of information. That's a union of all the possible information. That's not just what one or two set of silicons are able to provide. Now, flow definition, when I look at the flow definition essentially means flow data set. Flow is qualified by by 5 tuples. That's possible. Flow is qualified by more than 5 tuples. That's just the qualification. Then for a given flow, what data need to be collected, and a very simplistic way, the data is flow statistics. You can get additional data, as I said, that maybe flow can also be classified, whether it's an elephant or mice. That's additional set of data, and that's just what I'm thinking. Maybe there is another implementation which thinks of a much better data set, and that should fit here. I'm not precluding anything. I'm saying that this should address all of them.
We are not precluding anything, neither in detail, but let me just go back to the first question, please. So how can we prevent some, let's say, management flows not to be monitored by in situ OAM or INT, because they can actually increase the MTU size of the packet? If I want to prevent that from the beginning, is there a way in this API classes?
So what do you mean by management flows?
I mean, as a user of this API, they may want to monitor certain set of flows, but not all of them. You know, you may want to exclude, for example, let's say report traffic itself. If you are monitoring the report traffic, then you are kind of creating loop of monitoring. You're monitoring the report traffic, and also they can create reports, and you are monitoring them again and again and again, right? You probably want to exclude certain set of traffics from the set of traffic that you are actually monitoring. There are multiple cases for them.
Mm-hmm.
Then it's not clear how we can actually clearly define what set of traffic to monitor or not in this API set. Can you please help?
So let me try to understand. I'm still a little bit fuzzy on the question. So let's.
I think, JK, I think it's still, you know, yeah, that specific problem, I think I understand, but still, I think, you know, on the very high level, the J has been defining here flow is, but in the ASIC, it's internally tracking the flows, identify flow, collect flow statistics. It's, I think, inherently different from what the INT proposal is about. You know, Jay, I think I totally understand you that, you know, the ASIC need to be able to track the flow, you know, identify some property of the flow, collect counters, you know, then expose those flow statics to the outside world. That's a very valid use case. I totally agree with that. But however, I think I still want to point out that your flow definition, your flow telemetry is different from what INT has been proposed, right? So but what it's very different from what you're saying. So why are they saying that just a match, you know, user define and match flows and then tag those packets on those flows and then basically process and send out? So that is very different from what I've been hearing from your proposal. Yeah.
So is it not possible to do both?
Absolutely, through separate APIs.
Yeah.
Yeah, that's different APIs, right? So your flow is about, you know, internally tracking the flow, get the flow statistics. But however, they are just define the match and then process per packetly. It's different.
So okay, go on. So I think what we are doing, we are mixing two things. One is, so okay, telemetry has now there's a like big topic, but let's take a step back. Okay, so there is one is a subscription that I want to subscribe for information, and then one is publishing of the information, right? Now these APIs right now, even in the current detailed APIs, there is no clear distinction where we want to subscribe for a given data set, and then what are the mechanisms for publishing the data set. In this proposal, what I'm doing, I'm trying to segregate them, and what we are focusing is that there is a different way to subscribe for a given data set. Okay, so you are saying that subscription is, I have these set of flows which are qualified by some ACL kind of mechanism, and then I want to monitor certain attributes on those enabled flow, right? That's the way I'm understanding, okay? So when I say
I think no, I'm not talking about. I think the in proposal is inherently. I think it's simple. It's marking. It's express the interest of the flow and then attach the metadata onto those packets.
Right. So expressing the interest is the subscription.
Where does your proposal cover those?
So that's going to be in the telemetry API class. So API will have essentially a way to subscribe for a data, right? And that's what I was saying. If you think that, I assure you that I will make sure that whatever subscription mechanism you have should be included or should be extensible. But if that subscription goes through an ACL, then that's not in the telemetry API. Then that's the ACL API, right? Then
yeah, but the telemetry API is about defining what metadata to be attached on the per packet basis.
No,
where do you cover those?
So telemetry API defines the data which either on a per packet basis, which is on the per packet API class. So API class has multiple objects. So per packet, that's what int is. That's squarely what int is mainly. Okay. And what you're saying to me is that there is overlap of int in a packet, per packet, and a flow interpretation. But that's not how I am reading it. What I am reading it, that the flow interpretation for you is essentially a subscription mechanism where you express an interest on a given or a set of flows on which INT metadata need to be inserted, right? Whereas in this, flow is actually a flow on which I want to monitor a certain set of attributes, right? So that set of APIs are completely covered in the per packet class, right? Whatever we call as int. And I'm deliberately steered away from calling it int. We call it as a per packet data class.
Yeah, so int is one of the data plane telemetry methodology, right? We can do postcard, in situ OAM, DPP. It's not really limited. But what we are just talking about is the core key of data plane telemetry is first defining which packet or set of packets to monitor, right? And then this is basically match capability. So when we say accurate, it's not really security accurate. We are talking about the accurate slice as we use this also for mirroring actions, right? So SAI accurate is defined very flexible way to add any particular arbitrary actions or match fields. So that's why we extended the existing SAI accurate API to just easily define or confine the set of packets of interest. And then the action will tell us which telemetry will come into play, right? Either INT, in situ, postcard, any other things, right?
Mm-hmm. Mm-hmm. Tell me one thing. That was JK, right?
Yes.
Yeah. Okay. So, and this discussion you guys have already had. The ACL APIs, they could very well be just a way to enable a given telemetry API. So why did we not consider a higher level telemetry API, per packet telemetry API, internally, which uses the either ACL mechanism for some other switch vendor? It may not be ACL mechanism. It may be completely something different. Now, how that API gets underneath implemented or enabled would have been left to implementation.
Exactly. That's why we don't care much about merging the APIs, because existing API does the job perfectly and flexible. We can just start from there.
Yeah, yeah. I have no questions on that. Yeah.
I think that's what the previous telemetry conversation goes, right? So I think we should reuse what we already have in the side. For example, in terms of defining what flows are interested. The ACL did a pretty good job, and all the vendors currently support that. So it's widely supported. So yeah, so I think what we have been saying here is that basically defining what the flow is being interested is not part of the telemetries. At least it's ACL, right? It's not covered here. And I want to go back to the point that you mentioned this per packet class telemetries. So I look at the, your slide 3, the next slide. I think it's basically very similar to what the INT proposal has been doing. Am I correct there?
So I have made a conscious effort to include the INT proposal seamlessly into this. So the conversation, the data you see on that, I have deliberately kept the INT proposal and shown that how easy it is to migrate to this hierarchy. So that is all what was there in the INT proposal. You are absolutely right.
Okay, yeah, that's good. So I think so. Then it looks like, for this the INT use cases, particular use cases, the INT proposal actually does have the right architecture, and in terms of your framework, right? So because basically the INT proposal is echo plus the per packet telemetry class. It's just kind of a rewording, but what I'm hearing is that the current INT proposal does align with what you have in your mind. Am I correct?
To larger extent, not to complete. So I think in somewhere in my early, I don't know if you joined late, but I did mention, went in detail on that the current INT proposal do not segregate the APIs neatly. So event and event actions and reporting, they are kind of tightly coupled together without clear delineation. And same thing is the event and the telemetry APIs. So the boundaries are not clear. They kind of just seamlessly go into each other's domain. And what I'm going to do, I'm going to, let me just put the slide, which is what we want to achieve. So this is, I have specifically called API mapping. So I'm going to tease them apart, make it clean. So it's very easy for the detail API proposal to be absorbed here. The per packet, the INT APIs will cleanly go there. I'll do the segregation of the events and put them neatly into the event, and anything which is a reporting will go in the reporting and a collector class. We don't have a collector class today. Okay, so that's what, and you're right, I have taken the detail as an example and shown that this is what we are going to do that. I have one question for you, and maybe it's being discussed before, that the subscription APIs, we call it right now as a ACL APIs. Does it make sense to have a wrapper on top and underneath the implementation if it wants to call ACL? I mean, think OpenFlow, right? So OpenFlow underneath we want to achieve through the TCAMs or through the ACL entries. That's left to the implementation. But high level, they are looked upon as the telemetry APIs. Does that make sense? If that makes sense, then I can propose a subscription APIs in the telemetry API class, and they actually achieve their functions by calling the ACL APIs. But I want some sort of guidance on that.
No, but here's the challenge that I say. This is Daniel from Barefoot as well. I mean, we've been through this cycle of reviewing APIs for 6 months, and if there's any additional feedback in terms of improving the API proposal that we have in place, we've been accommodating of every single feedback that has been submitted. I don't understand what we're now, 6 months later, trying to revisit and starting from scratch in terms of defining a wholesale API structure that the reality is that there's no precedence and there's no need in terms of wrapping up functionality in some overarching API to implement this functionality right now.
Well, Daniel, I don't agree with that.
As have been discussed, there's the opportunities there. If in the future there's a need to do consolidation, architecturally, the flexibility, there hasn't been any point in terms of saying that the existing proposal is not flexible or extensible. So I'm just trying to see why we're restarting the clock on an API definition that's been that's been discussed, debated, and improved over the last 6 months.
No, Daniel, I think the whole conversation, at least my engagement, got started here because there are various data sets which we want to expose, and at least in the current proposal, that was not cleanly possible.
No, they are exposed. They're just not in a converged API. Everything that can be exposed in the control plane can be exposed today through the TAM API. There's no resistance to evolving both APIs in parallel. I mean, there's value in the capabilities that both APIs willing to see an overarching need to suddenly try to do this massive API convergence for functionality that is completely orthogonal.
Are you saying that we should keep both APIs, both the current one that we built and also provide the subscription-based telemetry class API? Is that what you said?
I mean, we have a couple of slides. I'm happy to go through that and highlight what our proposal is.
So sorry, Jay, this is Ashok. I was having some audio. Can you hear me?
Yeah, we can hear you.
I'm muted.
Okay, so Jay, do you mind flashing the API changes slide that you were the document that you were working on to address if there was?
Right. So that's just a capture of the discussion, but I think Daniel has a more fundamental concern that why we are discussing it, and I'm not the right person probably to answer that.
So I think part of it was when we looked at the APIs, we also felt that there were some attributes were missing from the existing proposal, correct? I mean, I was trying to address that. I mean, his concern is, okay, if there are specific objections or enhancements we would like to see to the existing proposal of APIs, or API proposal, rather than maybe we should present this also. And maybe we should present that with some of the changes that you've been considering to the existing set of data plane telemetry APIs.
Yes, so I did talk about lightly in this slide that there is information which is missing in the current, and these are the detail API objects which they are missing. Right, so some of the blue ones which I have highlighted here, and these are just some. There's quite a bit of information which is missing, and I have taken.
I disagree. It's not missing. Those are the existing components of the TAM API. My suggestion is that can exist independently of our proposal. I mean,
and just to add to that, for example, the session type or session attributes, like you said, we also define those as an enum list. So there is no, we can easily add an entry into the enum list. And I think your comment on INT and also IOM was not entirely true because, yes, there are a few number of data types, for example, switch ID and ports, etc. But this is not a definite standard, something like that. It's evolving, and then actually we are collecting feedback to add more entries or data types or even opaque ones, TLB type ones into INT or IOM. So as an API detail, it's not any of limited to what current INT or IOM spec defines in terms of metadata to collect. If the INT, IOM, any other underlying mechanisms evolve, as an API, detail or SAI API can easily also incorporate them, just adding entries or attributes into the existing enum list.
That's where my disagreement is. You cannot. The current detail API is a mess. It is so overlapping into various classes. The boundaries aren't, it's not even extensible. It is such a mess. So I strongly disagree with your statement, JK.
Can you, okay.
I have gone over the whole presentation was about that. So I don't know what else you want me to say. I started with clarifying those things. And I can tell it again, I can say it again, that the events, you don't even have a clean notion of probe in the current API. The event and the reporting, they're all mixed up together. And not only just that, the events are kind of mixed up together together with the telemetry APIs, there is no way for me to add seamlessly any sort of things which I'm talking about here.
Actually, there is a good comment from, I think, Dell, to make the telemetry events as a maker attribute. So actually, we are in the middle of making the simple changes to make it really extensible. So it's not really requiring defining a new set of APIs. We can make a very small change to make it really extensible, to incorporate not only telemetry classes, probe classes, event classes. Yes, we don't have such a report classes, but in a way such that we don't really expect many data plane can generate something like protobuf. If you can do it, then let's just add it. But there is no point of merging all the APIs overarching from SNMP, NetFlow, SFlow, detail into just one class. If you don't mind, we can actually jump into the set of slides we prepared, just a few slides. I think that'll be easier for us to just compare the two approaches.
Right. How about let's go to do that? But please note that many of us have a hard stop in 10 or 15 minutes. Yeah. Sure. KJ, do you mind? Yeah.
Yes. Let me
go ahead.
Okay, that. Who needs to share their screen?
KJ, me.
Okay.
JK, how can I start?
Okay. Yeah, JK.
JK, I'm promoting you, and then I'm making you a presenter, so you should see a pop-up.
Okay. Let me show my screen.
And you're having some echoing going on when other people are speaking, just FYI.
Yeah, if you are not speaking up, please mute. Yeah. So after this, let's go back to think about it. Let's resume the talk, discuss next week. I believe this topic deserves more time.
Okay, we can see your screen, JK.
Okay, thanks.
JK, mind asking, sorry, which company you with?
Sorry, this is Daniel and JK from Barefoot. So we just kind of wanted to sort of bring to light the whole landscape of telemetry, right? We're talking about many different things, and you can decide how to partition the telemetry landscape in multiple areas. And the obvious area for us is that there is a clear differentiation between what kind of telemetry information you can collect through the control plane in terms of both the information available and the amount of reporting capability that you can generate through the CPU. And then there's this new type of telemetry that we're trying to introduce through this API, which is strictly data plane telemetry, where there's zero involvement on the CPU level. So to us, it really changes the semantics of what the existing telemetry APIs currently provide today. Further, from the point of view of telemetry objects, there's been, in the past, there's been sort of siloing of different telemetry solutions depending on the type of object you want to provide information about, whether it's a device, the network, flows, or even to the packet level. And what we're saying is that with the API and the reasoning that the API is structured the way it is for detail today, is that we're really spanning the whole telemetry object space. There's really no differentiation in terms of whether we're collecting device information or network information or flow information or per packet information on our in-band telemetry data. Go ahead. And historically and sort of precedence-wise, there really hasn't been a need to necessarily converge all of these APIs into one common API framework. I mean, as of right now, all of these APIs have been developed separate to enable the quick development and the quick prototyping and the quick future enhancement of each of these telemetry methods. And I think our suggestion is that we continue on this path. Let's decouple the APIs, let allow for each of these technologies to evolve independently without having to carry the burden of full legacy API support for some of the other capabilities that exist in telemetry today. And we talked a little bit about that today. I mean, I'm happy to, we're happy to have this discussion. I think we've been sort of very open in terms of accepting feedback and converting feedback and receiving feedback. But this has already been a 5-month process from our point of view. and it kind of sounds it's not ideal to restart the whole definition of what this API should look like from the ground up by trying to do some massive aggregation and overarching hierarchy of an API that is really, I mean, at least in our analysis, we haven't really shown or been able to identify any overlap between the APIs that we're trying to converge today. They're really completely independent APIs. And again, the main distinction that we're drawing is that there's value in extending, you know, telemetry APIs that mainly focus on generating statistics and counters and perhaps non-specific per flow information, and that's, you know, I mean, the reality is that time today is very limited, so, you know, it's kind of, I'm failing to see how we were expected to suddenly rebuild TAM into a framework that was fully inclusive, because there wasn't a framework in place to necessarily do a converge API. And we built in general a very flexible and overarching API for all the data plane type of telemetry that we've seen in our.
But at the same time, we see the great use cases of the existing TAM or, you know, control plane based APIs. For example, this means that the local CPU can do some analysis or more processing of the data before reporting to the outside of the switch. This is great, but it also has a limited performance and granularity, which means that it needs to rely on samples and statistics. So in many cases, that could be just sufficient. So I think TAM is great as it is, and it can also evolve within this framework. But at the same time, data plane telemetry is, you know, addressing almost completely different type of users and then applications, particularly in the hyperscale data centers. So that's why we are looking at something like in-band telemetry that can monitor each individual packet over the network. And it has a very certain set of benefits, like precise information over every packet and direct correlation between each individual event to the packets actually creating the event or suffering from the event. This is a very unique property of this data plane telemetry, but also requires some more powerful processing at the monitor. So that's very two different you know, approaches between the control plane driven and data plane driven. Yeah. So
if I may say something, this is Nikos from LinkedIn. So I don't see how what Jay proposed from Broadcom restricts us or contradicts what you're saying here. I think, if I understood correctly, his proposal is just trying to capture a hierarchy of the APIs. Now, you can underneath do whatever you like with those APIs. You can go to the data plane and monitor every packet or subscribe to every packet, but ultimately each API that you'll end up proposing will fall into a category of APIs. Do I want to subscribe? Do I want to probe? Do I want to, you know, do something else on every single packet? It doesn't come in contradiction.
The semantic, I mean, it's kind of easy at this level to try to say, oh yes, everything lands on their telemetry, but the semantics of the data plane telemetry and the control plane telemetry are very different. And to try to forcefully converge them into a single API is
no. I'm not suggesting. Okay, so I'm not suggesting to try to forcefully convert them into a single API. I was leaving that part out. I don't think that we should do that. But I'm still in quotes, a fan of the idea that the grouping of the APIs or the telemetry functionality is a good thing. I need to understand, and the overlapping, or at least if there is an overlap, and to what extent is a bad thing. Because I need to unambiguously be able to determine, say, okay, if I want to do function X or probe Y or telemetry Z, where does that fall in my classes? And I want to be able to clearly identify what is the right API for me. Because as things progress, especially in the hyperscale data centers, the number of APIs will increase. as well as the capabilities of the silicon. So the number of APIs will proliferate, and having a flat set of APIs that runs into the hundreds, it doesn't make it easier for me to use, even if it's easy to identify for some others what is the right API for the specific silicon. So I'm not advocating for the merging or the forceful merging of APIs, but I am an advocate of, well, the functionality can be grouped into classes, and from then on, try to define APIs. And what is the right way, we can discuss whether it's ACL based or something else for some functionality, but certainly
Nikos, I don't think that in the current proposal, it's not separating those different APIs. So they have report APIs and they have in-station APIs. I think it is separated, right? So in terms of we're adding those metadata versus reportings. So I don't think that the statement is correct that the in proposal is not separating those APIs into different groups. So what I'm hearing is that on the high level, I think this inter proposal is aligned with what the broadcast proposed. I don't see that that there's some fundamental drawbacks of the that with the proposal is not flexible or it's not fitting to the Broadcom's telemetry API architectures. I think it does fit that architecture.
So Guan, can I make just one comment? So I made that distinction, and I believe that was Nikos talking. So and Nikos is absolutely right. That's what the thinking is, that we should have a hierarchical API, which gives us ability to drill down on a given domain, and then the data plane APIs essentially become a subset of those or one of the domains in that hierarchical API set. Okay, so that's the one thing I just want to highlight. So that's the key difference. Okay, and the second thing is, even in the current detail API set, when I went ahead and said, okay, can I push my data objects in the metadata, I did not saw a clean way to enumerate that. Okay, it was tightly binding me into the current objects, and there was no clean way to enhance that. So these are the two observations which I made, and based on that, what I did was came up with an overarching hierarchical model, which is more scalable. And the second came up with minor enhancements in your proposal, which will not go through major change. But does it addresses all that concern? No, I don't agree with that. Okay, is it gonna go through major change? No, I don't agree with that too. With minor modifications, I can get my things done in that. But should it fit into a bigger hierarchical model? Absolutely yes. Okay, so that's just the way I am looking at it. I just wanted to put it on the table.
I agree that if you just take a look at it from really too high level functionality, the control plane approach versus data plane approach may look similar, but actually when we correctly try to use those APIs, we need to have a somehow different mindset. For example, the data plane telemetry APIs and objects, by its definitions, they are interacting with other data plane objects. For example, I'm just pulled out these SAI object models in our GitHub repository of SAI. And then if you just take a look at for ACL, for example, where the ACL object interacts and located in the overall relationship between other object models, whether it's coming after port or before the router interface, is very important. Because when we configure the ACL table, we need to know that the meaning of the, for example, 5 tuples is before or after tunnel, in-cap, decap, etc. So in the same way, ACL table is interacting with many different cases. And for example, our detailed watch list is also interacting with those other data plane objects, and where the telemetry watch list is happening in the data plane object relationships, and then data flow is also very important to understand. And this go further. This is all about the ingress pipeline. But if you talk about some other metadata we can collect, ingress or egress, basically there's a major difference between how we collect even for the queue information. The queue information becoming available in the pipeline in the data plane. That's the detail or any data plane telemetry can collect, and also add another event or probing mechanism over there. But the way the same data is collected from the control plane and CPU is very much different, because the data model and then transport model or probing model all sitting on the driver and CPU. So when we actually using and configuring those objects, we need to keep in mind that where actually it's happening and then how it's interacting with other data plane components. That's not really needed from CPU-driven approach, but when we configure data plane telemetry, we need to be very much aware of them to some degree. Otherwise, the semantics can go wrong.
So Jay, I think I'm not completely agree with your this having a hierarchy. So so basically, what I think is that, for example, in your telemetry APIs, you have the per packet telemetry class and a flow class. However, the telemetry we want to get from this different type of object is completely different. If we are talking about the packet, is per packet information, the instant queue length, output port, the outgoing port. But if we look at the flow data, it's inherently aggregated data, like the maximum number of latencies, average latencies, right? So I think those data are completely different for different classes. So I'm not sure that benefits to put into the same hierarchy. You actually have a base class for this inherently vastly different two types of data sets you are trying to collect.
Can you hear me? Yeah, Bhaskar, we can hear you. So, Ron, just one comment on that. So there is one confusion I see that that there is some CPU or control plane telemetry which has been incorporated in the proposal. That's not correct. I know in the existing TAM proposal, there is some control plane telemetry which has seeped in, and that need to be cleaned. We are focusing squarely on the data plane telemetry domain, right? So I just wanted to clarify that. And when we say about flow statistics or flow data, I'm still talking about capability of a silicon, okay? And as I said that every silicon is different, capabilities are different. Now, to your point, the telemetry API class, does it have a subclass of a per packet telemetry or a flow telemetry? I think yes. And as you yourself said that, they achieve different functions, okay? So I'm not denying what you are doing is not needed. It is needed, but it's a separate class of function, okay? Let's say that I have a 7-Eleven who is my customer, okay? And they do not want to really get a per packet telemetry. They said, my information, which is at a flow granularity, is good enough for me. I don't even have an infrastructure to consume this. So they are not the hyperscale data centers. So that's one class of application. Now, I think we should address that, and hierarchical model is always considered more scalable. First, it's easier to visualize, it's easier to implement, and second, it gives us as a community a lot of flexibility to innovate in individual subdomains. If we have a flat model, then we keep on stepping on each other's toes, and that really does not work well.
Yeah, I mean, looking at it as a hierarchical model is one perception, but the way I see it is more of a versatility, right? You need to look at it from application point of view, and what problem you are trying to solve point of view. It doesn't really matter whether the telemetry you are gathering from application point of view? Is coming from in
So,
the data plane packet?
I think on both sides, right? So let me put
go on, let me come to
so let me finish. So I think on both sides, there's there's arguments, right? So on one side there's argument that those data are inherently different. How could we aggregate them in a meaningful way? On the other side, there is an effort trying to do the architect to aggregate them. I think those two efforts are both those concerns, the arguments are both valid. I think it doesn't. I'm not saying that I don't think that we really should to solve this in the meeting. I mean, probably we cannot really solve this argument in the meeting, right? So because these are arguments, right? So I think the best way is to so for the current telemetry APIs, I think it does serve the purpose. I think it nicely fits into the current SAI architectures, be able to leverage the echoes and existing infrastructures, and then just adding a few objects and be able to help them address those scenarios. I think, and I think on the other side, well, on the Broadcom, you have this overarching approach. I think we should also let that go. So what I think we talked last time that for this SAI telemetries in proposals, we can consider as experimental proposals. So Barefoot, are you okay with going those approaches, or what?
No, Gohan. Again, this is Bhaskar. In my view, SAI is becoming more and more important, and it is getting more traction. So you don't want to go in a fragmented approach where you take one thing and then only solve it with that narrow angle. This is an opportunity where we consider this telemetry as a strategic thing for SAI and its customers, and then make sure this is not only addressing one particular way or one particular feature or one particular method of gathering telemetry. When you have, let's say, an interface statistics or a buffer occupancy, you can get it from CPU, or you can get it embedded in the data plane packet and ship it out on the data plane itself. When it comes to application, all it matters is how frequently I am getting, what is the granularity of the data. It doesn't really care whether it came from this port versus that port, or whether it came from data plane or from control plane. What we need to solve is
why are we restricting the capabilities of the system? I mean,
no, we are not. Maybe
you just grab a situation where you think you know exactly what is needed and what isn't needed, and we're providing an open API that the customer can control the amount of reports that they can that they receive, the granularity of the data that they can get on a per flow per packet basis. I mean, I see 2 points here, right? That the discussion is getting dragged into two main areas. One is whether these two APIs need to be converged, and the reality is that there's nothing to converge, right? There's our current proposal and nothing else already inside. So we're trying to converge something. We're trying to convert the detailed proposal with something that doesn't already exist. So to me, that in itself is a red herring, in that we should just work on extending what the detailed proposal is already providing. And there's two issues that have been raised, right? There's the issue that the current one hasn't, the detailed proposal today doesn't seem to have some opaque data type, which is not true, because it's easily extensible with any data type that you want to add into the in-band telemetry enum list. So that we can address very easily by adding a new enum into the existing API. And the other question that I keep raising is this question that I hear raising is this question of reporting, what events get reported where. And the reality is that right now, all of the data plane reporting gets reported to a single session or multiple sessions. So there's flexibility in, the reporting component, the reporting class of the API is fully extensible. There's nothing there limiting the ability to add additional reporting sessions into the API. So either we decide that there's something to merge with, which again, I'm not clear what there is to currently merge the existing API proposal with. And
yeah, but if you let me complete, then hopefully you will understand. You just interrupt and then go on talking, even though you had a few sessions to present this. Broadcom is presenting this first time. You are not hearing out. I don't know how we can, consolidate or, converge. So first thing is, you need to understand and you need to listen what we are proposing.
We have been listening for an hour.
It's about, monologue, right? It's about understanding each other.
Yeah, we've been listening for an hour, and also some of the statements made for the detail was not correct. That's why we try to correct that.
So sorry, we need to wrap up. Yeah. So how about this? We do have two things. Yes. Sorry, that OCP has to end this. Yeah. Yeah. Sorry. OCP, the organizer has to quit, stop in 2 minutes. So let me conclude this. Sorry to interrupt you, that we can come back next week, but we have two needs. One is to have a innovation evolving very fast and to satisfy some of the customers' needs. The second one, and independently, the second one is to have a framework that can be extensible. Let me suggest this. This proposal has been proposed as an experimental proposal. Meanwhile, we should let them go ahead as an experiment proposal. Meanwhile, Broadcom can continue develop this the framework you have proposed, make it concrete, and a bigger proposal in parallel. So whenever this is ready, we can see how do we take it from there.
Shin,
let's do it in parallel. Yeah.
Ready. The proposal is ready, and that is what we submitted. Maybe the community did not get a chance to go through it and understand it properly, which we understand. It's probably it will take time. To be fair with the community, right, and everybody. Let's let them give let us give more time to the community to review and then come back, so we can I don't know, I never fully understood the ways of working around experimental drafts. We came up with that telemetry and monitoring proposal, and we proposed experimental, and it only took more than a year to go through it as an experimental. Okay, so I don't claim to be an expert in
exactly, but we need to fix that.
No,
we need to fix that.
It's not experimental, right? So, it's not marked as experimental. The experimental proposal, the Dell has proposed that
definition there.
There is a document to discuss how to do the experimental proposals. Yeah.
Yeah, and this comes Kim like.
And was that reviewed and approved by the community?
No, it doesn't have to be agreed by all the community members.
Yeah.
That's why it's experimental.
Go on. You said Dell has come up with a document for the experimental, ways of working. Was that reviewed and approved?
Yes. Yes.
Okay. So we need to go. We need to understand that. And my suggestion is, rather than taking a experiment, I don't know how many community members have to agree on the experimental, but it's easy to just say everything as experimental, then it becomes a bunch of fragmented proposals.
Hello.
We lost them.
Is there a document? Is there a document other than the slide deck from Broadcom that describes in more detail the classes that are being proposed, along with what is the use of its hierarchy and its sub-component or subclass in those classes? Where can I find that to review?
It is a work in progress. We can publish, I think Bhaskar was supposed to give the dates. I do not own the dates, but I think it will be ready in as soon as 2 weeks.
So I think it's best then to table the discussion until we have something concrete to review. Personally, as far as I'm concerned, as the consumer of silicons, I want to understand the details of your proposal. As I said, I'm all in favor of classes. I don't think it's going to scale going forward, and it doesn't suit my needs as a SAI northbound user to have everything flat. That won't work. So, but at the same time, I share the concerns that everybody else has voiced. So I want to be able to understand a little bit more the details of your proposal. So when you have the document ready, for consumption or for sharing, please do so that everybody can review and comment on this, right? I mean, because otherwise, it doesn't get us anywhere to have this discussion.
Right.
Then we cannot
so yeah. Okay.
That's right. So that's what Xing has been proposed.
Evolving in parallel. That's evolving in parallel.
Yeah. Hi. I don't know. Somebody's muting me in the middle. Who has that capability? I just want to understand.
I don't know. It's the
organizer. Your audio dropped off in the middle of you speaking. The organizer didn't mute you, but go ahead.
I dropped. Yeah. Yeah.
Okay. So yeah, my suggestion is before we make it a bunch of fragmented things that nobody will understand what it is.
Bhaskar, this is just one thing. When you dropped, there was a suggestion that we should put our proposal, and that was from the northbound interface, probably from Nikos from LinkedIn, that we should put our actual header file detailed proposal for community to review so that they can come up on a better understanding and decision. So just wanted to update you on that.
Yeah.
Sure. Yeah, I think that's a good idea. And I also heard, the flat thing will not work, which is what we are hearing from our other customers who are interested in SAI as well. There are too many things and too many fragments. So that is what motivated us to come up with one proposal that accommodates everybody, including the Barefoot's current proposal. Somehow people are taking it as a conflicting or a contradicting thing. Actually, it is a more accommodating proposal. So I really suggest people take some more time, review the proposal, and we can convene and discuss.
So Bhaskar, we all agree that take more time, and after you write the proposal, let's come to discuss that. The only thing is that let's evolve in independently. That so experimental proposal, go ahead with experimental. When your framework and the proposal are concrete and ready to discuss, we are very open and happy to regroup and to go from there.
Yeah, sure. Again, I need to go through that experimental standard ways of working, and I will provide my feedback.
Sure. Okay. Sorry, guys. This is an interesting discussion. Thanks for your time. That I will share the video recording. Thanks, Kelly and Michael, to be online from OCP.
Thanks, guys. Bye bye.
Yeah. Thanks. Yeah.